Albert Einstein predicted that we would never be able to see to the edge of the universe. The James Webb Space Telescope has now observed a void in the extremely early universe that could confirm this prediction. But what are we really seeing here? Is it truly a void, and could it be the beginning of the universe? Scientists may have discovered a shocking fact: a strange void at the beginning of time may now confirm a remarkable prediction by Albert Einstein. Imagine how, 100 years ago, scientists slowly began to look beyond the edges of the Milky Way. What they saw astonished them. At first, it was just hazy nebulae, but then it became clear that these nebulae were other galaxies. First, the small and large Magellanic Clouds became visible, then the Andromeda Galaxy. Finally, the shocked scientists realized how many more galaxies there were. Based on these findings, ideas such as the evolution of galaxies and the infinity of the universe were born. Then Edwin Hubble observed that distant galaxies were moving away from us, and the idea of expansion was born. Shortly afterward, the Belgian scientist Georges Lemaitre came up with the Big Bang theory. This all took place slightly after Albert Einstein presented his theories of relativity. Many of the theoretical predictions made in the 1910s and 1920s were confirmed by these new discoveries. However, Einstein was unsure throughout his life whether the universe really had a beginning and an end, although he fundamentally accepted the Big Bang theory. Nevertheless, Einstein was always sure about another interesting question. Even if the universe did have a beginning and an end, he was certain that we would never be able to see them, no matter how good our telescopes were. But how did Einstein come up with this idea, and what does it have to do with the void discovered by the James Webb Space Telescope? Albert Einstein's devastating prediction. Einstein was certainly one of the most important physicists of the 20th century, making many predictions that remain cornerstones of modern science. One profound consideration was his prediction that we could never directly observe the absolute beginning of the universe. Einstein provided two interesting reasons for this. Firstly, the Big Bang theory and other related theories postulated that there was no light for hundreds of thousands of years immediately after the Big Bang. Today, scientists call this epoch the Dark Ages. How could we see a point in time or an event with telescopes when there was no light? There are some exciting answers to this question today, such as radio telescopes, which do not see but hear. However, researchers are quite certain that the Big Bang was not a loud explosion but took place in complete silence. The space in which an audible explosion could have occurred did not even exist at the time of the Big Bang. Space itself only came into being as a consequence of this event. Radio telescopes detect waves that are usually far from the audible sound spectrum. Space hardly conducts any sound, and only a few other waves penetrate the interstellar medium, which can be made audible using modern technologies. Therefore, we would not truly be able to hear the presumably silent beginning of the universe. We discovered the cosmic background radiation back in the 1960s and have since mapped it extensively. This radiation is considered an aftereffect of the Big Bang, providing much evidence for the theory. However, the microwave background has never directly led us to the Big Bang itself, meaning we still have no way of detecting or proving the absolute beginning. Einstein had another reason to believe that we could never see the beginning or edge of the universe. He suggested that due to the expansion and extension of the universe, the beginning would continuously move further away from us and remain out of our range of vision. At times, Einstein also believed in a curvature of space, meaning that the starting point could be hidden behind a kind of horizon that would forever obscure our view. Now, imagine that this was a time when the best telescopes could only blur the images of neighboring galaxies. Today, we know of millions of galaxies in a universe that continues to expand and grow larger. One might think that such an expanding cosmos would make it impossible to see far, but that is not the case. Despite the vast distances between galaxies and galaxy clusters, we can now observe the universe as it was 13.6 billion years ago, very close to the time of the Big Bang. With the James Webb Space Telescope, we are already seeing extremely distant regions of the universe. However, the telescope has not shown us what scientists once called the Big Bang. A strange void. The JWST has discovered an extremely large number of very old galaxies that now even call the Big Bang into question. But did you also know that it has discovered a strange void that could confirm Albert Einstein's prediction of the non-observability of the absolute beginning? Absolute voids are mysterious spaces in the universe that are so empty that they actually contradict the theory of relativity. But how can they confirm Einstein's ideas about the invisibility of the beginning? Initially, this was explained by the fact that the emptiness was thought to be an indication of the Dark Ages, a period when there were no stars and galaxies. Some researchers believed that the discovery confirmed the existence of this epoch. Then came the shock: the darkness turned out to be an extremely distant void. We also know of closer and more recent voids, which already pose puzzles. But in the extremely early universe, voids should be scientifically impossible. They do not fit into the idea of the homogeneity of the universe, which is directly linked to the Big Bang and the theory of expansion. Voids are too large and too strange. They have an inhomogeneous character and contradict some fundamental principles of cosmology. While a void does not necessarily confirm Einstein's prediction, the James Webb telescope seems to confirm his view in another way. So far, the telescope has found no trace of a beginning or an early stage of the universe. The images of the allegedly extremely early universe only show structures and galaxies that do not appear much different from those we see in regions closer to us. Could a void have been the beginning of the universe? This raises an intriguing question: could a mysterious void have been the origin of the universe? We cannot completely rule this out, as we still do not fully understand what voids truly are. Voids are probably empty, but we do not know that for sure. They might contain some kind of matter that has yet to be discovered. Some scientists have even speculated that voids could be remnants of cosmic collisions within a multiverse. Other bizarre theories suggest that advanced civilizations could be deliberately darkening galaxies in a void to harvest energy. It is even possible that our universe was created within a large void. The fact that we cannot disprove this idea only reinforces its possibility. This brings us to another fundamental question: how was matter created? What are singularities? We have already discussed the idea that the universe emerged from nothingness. If that was the absolute starting point, how could we observe it? After all, it was nothing, and therefore, not detectable. A singularity is a point where all forces are so condensed that our known measurements of size and scale fail. It is a state of complete equilibrium until a previously unknown event disturbs this stillness, leading to creation. This means that everything we know, the universe, galaxies, stars, planets, and even life, was contained in an infinitesimally small dot of nothing. This remains one of the greatest mysteries of science, and it is unclear whether we will ever solve it. Singularities also exist in another place in the universe, the centers of black holes. Every known galaxy contains a supermassive black hole at its core. However, what lies within them remains unknown, as the forces inside are so extreme that they exceed our understanding. With new supercomputers and advanced artificial intelligence, scientists are now hoping to decode the universe's deepest secrets. Whether these efforts will finally unlock the truth about the beginning of the cosmos remains to be seen.